ask any questions about what we talked about on Wednesday. I know we covered a lot of stuff. It was pretty technical, and I was moving very quickly. Do you have any questions on what we discussed on Wednesday?
Lloyd's in here. I'm hoping that we will take the opportunity to go over the tray system sometime today, or is that part of your program?
You broke up a little bit there, Leighton. So is your question is talking about tray fermentation more specifically?
Yes. Are we going to look at that in details?
We're not going to do that today. If you have, I'll tell you what, if you've got specific questions on tray fermentation at the end of this, why don't we just sort of hang out at the end? And if we just need to have a one-on-one or a separate conversation outside the scope of drying, we can totally do that.
Beautiful. I'll take you up on that one.
Okay, fantastic. All right. Any other questions on what we covered yesterday from fermentation? All right. Well, I'm gonna give you guys a bit of a quiz then.
Before you start, I might as well butt in again. I always thought the heat is important or fundamental to the process itself. If we maintain the heat at, I think it's between 30 and 40 degrees, how essential is that? Or is it, could we sort of create artificial temperature control? Would that help the process?
Yeah, so we talked a bit about thermal control and heat yesterday. We didn't talk about specific degrees, right? Do you have to hit 40? Do you have to hit 42? Because there is no one right temperature. You do need to get to a certain temperature in order to kill your bean and to generate some flavors. But depending on which flavors you're trying to create, those temperatures change a little bit. And if you joined us on Wednesday, I had a graph up there that demonstrated how you can use a data logger like this to measure your temperature every minute or every 5 minutes or every whatever, and then understand what your range of fermentation is, so that you can then on subsequent ones come back and just quickly measure it to see is it behaving how you need it to behave. So yes, temperature is very important, and what helps to achieve that temperature and maintain that temperature is being sure that you've got enough quantity of beans in your fermentation so that it's called thermal mass, so that you're maintaining your thermal mass and you're not losing that heat to the atmosphere faster than you're generating it. So the second part of your question, I think, was can you artificially heat up that fermentation to supplement the heat that the beans would be generating themselves? I'm going to connect some dots that may not be there, Leighton. Are you asking that question because you're interested in fermenting small quantities that don't generate enough heat and are wondering, can you create an incubator to try to find ways to ferment small quantities?
Yeah, something along that line. If we have sort of low volume, if we create an environment that will maintain a steady, heat level, would that help us?
Yeah. The short version is it's complicated. so yes, it can be done, but there's a cost to it. And so I'm trying to think of the right way to describe this. And so you can absolutely create an incubation chamber that holds a temperature of, say, 40 degrees, or is adjustable, right? So at day 2, you're at 40, and then you turn it up, and at day 3, you're at 44 or whatever, right? You can create a temperature profile by adjusting the heat in your chamber. You can do that. What becomes more difficult to control for is, and we didn't talk about this yesterday because this is a much more advanced topic. It has to do with the way in which your atmospheric oxygen interacts with your pile. So how does it oxidize your beans? And when you've got a relatively large box, right? Let's say we've got a box that's 1 meter by 1 meter that holds about 600 kilograms of beans. Most of your beans are inside that box where the oxygen can't get to it. At the very surface of your box and on the sides where you've drilled holes, that's where oxygen is now able to come into direct contact with your beans. And early on, if you remember, the first phase of fermentation is the anaerobic phase, where we don't want oxygen to participate, right? That's not what's driving the chemistry that we want. So in a big box, you've got a little bit of your beans being exposed to the oxygen right on the top of the box, but everything below that, right, the other 590 kilograms of beans is shielded from the oxygen in the atmosphere. It's called volume fraction. The fraction of your volume that's being exposed to the air is very, very small. Now, what I think you're talking about is, all right, you've only got 20 kilograms of beans or 10 kilograms of beans. How do you ferment a smaller quantity? You can put them into a cooler where it's hot, or an incubation chamber where you're controlling the temperature. And now you've solved for your temperature problem, right? You don't need those beans to generate the heat. You're doing it via another method. What the problem you're going to create, though, is the amount of beans on that small pile as a percentage that's exposed to the air is far higher. So in your big box fermentation, where you maybe had, 2 or 3% exposed directly to the air because all of it's in the box, on a small pile, because there's so much less mass, now maybe you've got 20 or 25% of your beans exposed to the air, and it's going to ferment very, very, very differently. It's going to be difficult to control. So it's a long way of saying, yeah, you can do it. It's going to require much more precision in your temperature control, and you're going to get a very different product than you would had you fermented in a larger quantity. And it's typically, and different isn't bad, right? I want to be really clear about that. Just because it's different doesn't mean that that's a bad thing. But if what we're chasing here is a cocoa of excellence flavor profile that's going to generate higher values than the rest of the world, this oxidation problem that we're creating when we're trying to ferment small quantities is going to push us in the opposite direction of where we want to go from a cocoa of excellence flavor profile. So it's a really long way of saying, yeah, you can do it, but there's some pros and cons to it, and it's probably going to take you in a direction that's not going to be driving the most value for your beans. So let me, I think you're muted there. Let me just stop for a second and make sure I answered your question. Right? I didn't answer a question.
You have it's more complicated process, and would need close monitoring if we go that way. It can be done, but it's an awful lot more work.
Yeah, and your flavor is going to go in directions that are not going to be consistent with where the highest dollar for bean value is going to come in.
It's going to be right,
but it can be done.
But Lloydson, there is if Scott doesn't mind me coming in for a second, there is an alternative way of being able to do that, which is doing a big fermentation but with different beans but separated. So you'd use like the equivalent of like the bags which you get oranges in and stuff like that.
Yeah, the bags.
Yeah, absolutely. And then doubling up as a way of being able to combine different places. There's going to be an impact to it, but you will get that critical mass. But it requires cooperation if that's going to happen. And also, I'm sure Scott would probably say that there's some other chemistry going on which would be messing about with it being truly single origin if different places are coming in with different yeasts, etc., in that fermentation.
Yeah, so I think it's a good point, Nick, that that's one of the reasons toward the end of our talk yesterday, when I asked the question of what's better, to ferment at the farm or at a central fermentary, and where I'm at is it's usually better to go to the central fermentary for exactly the problem or the challenge that Lloydson is talking about here. Oftentimes farmers can't generate 300 kilograms of beans in a single harvest. So combining and working communally or working with your neighbors is a really easy way to get there. And there's a couple ways to do that, right? You talked about sort of individual bags of beans, everybody's bags goes into the box. You can do it that way. It's a little bit more labor intensive to do that, because then you got to open up bags and reclose bags and turn bags, and it's labor intensive. So there are other ways to think about that. But Luyten, if you've got a specific reason why working with in a community setting doesn't work for you, and you want to explore sort of this micro fermentation, we can talk through that a little bit more. I don't know that I want to spend a lot of time with the whole group, just because it's really complex, and you're also going to run into mold issues that we're not going to run into on larger batch sizes. But we can one-on-one maybe talk through that and see if there are solutions that would work for you that may not be appropriate for everybody else. Okay. And it wouldn't be a teaching session if I didn't ask a pop quiz. So, and this is going to be the only quiz I ask you guys, I promise. Today, at least, anyway. Who knows about Monday?
Scott, excuse me, Scott. Before your pop quiz, I think there was a question in the chat.
Okay, I can't see my chat, so thank you.
I think it's Judith or someone who had a question in the chat.
Can you read it? I can't see my chat.
I've seen it again.
The question is, let me read it to you. Is there a market for chocolate that is not gold standard? And if yes, what area?
Sure. Yeah. I mean, that's your typical commodity chocolate, right? And so that's most of the chocolate that's out there. So if we think about, and I'm going to call it, this may not be the right way to think about it, but I'm going to call it low value cocoa beans or commodity cocoa beans. Those are the beans that are going to cocoa powder production or cocoa butter pressing, or frankly, just to, bulk average, everyday, normal, regular chocolate. There's nothing wrong with it, right? People buy millions and millions of pounds of normal, everyday chocolate. But for you guys, and I want you to think about the magic that is Jamaica, right? So you've got magical trees that are able to produce wonderful cocoa flavors that nobody else in the world has. And if you're going to try to compete with the rest of the world on commodity chocolates, because your volume is so small, you're going to get crushed. You're never going to be able to compete in a commodity environment with the Ivory Coast, just because they're Goliath, right? And nor do I think you should try. And the analogy I'm gonna use is, I think you guys have the potential to be a Ferrari plant. And if you're a Ferrari plant, you don't try to sell a bazillion cars to everybody for as low a price as you can. You want to make some really smoking hot, maybe half a dozen or a dozen really, really smoking hot, bright red cars that go fast, that everybody wants, but not everybody can afford, because that's where the specialty is, and that's where the value is. And when you do that, you can ask 3 or 4 or 5 times more for your beans than Ivory Coast does. So it's a long way of answering your question of yeah, there absolutely are markets for normal beans. I think for you guys, given the absolute magic that you have in your trees, that would be an unfortunate way to try to compete with the rest of the world. Okay. And again, I can't see my chat when I've got the presentation up. So if there are any questions, Nick, I'm going to ask you just to jump in and interrupt me and read the question if you wouldn't mind. Okay. So for the quiz, yesterday we talked about, all right, so now we're fermenting the beans, and there's a couple really, really critical quality things that will ensure that your fermentation is as magical as we think it can be, right? So who remembers what are some of the really critical quality attributes for fresh cocoa to give you a good fermentation? I'm not going to let you off the hook that easy, guys. Come on. How do we know if our pods are mature? What measurement would we do for mature pods?
Brix politics. Yeah.
Nice, perfect, exactly. So one thing we need to make sure is that we're harvesting ripe fruit, and we know it's ripe through the Brix measurement with a refractometer, because that's how we know we've got enough sugar for the fermentation to be successful. What's the other really important thing to remember when you're harvesting your pods? So for you farmers out there, are 100% of your pods healthy and disease-free all the time? Probably not, right? So, there's a variety of diseases out there. It is really, really critical that you not include diseased pods in your fermentation batch, because that's going to ruin all the magic that your tree has to offer.
We've got Marsha saying good quality harvest, and we've got Colette saying ripe beans, no disease pods.
Spot on. Well done, guys. Those are great answers. All right, so we're going to talk. Yes, so last time we talked about fermentation. Today we're going to talk about drying. We're going to talk about what specifically is happening during drying. We'll talk about why do we do it. We'll talk about different ways to ferment or to dry. Just like fermentation, there's lots of different ways that you can try. And of course, I'm going to have an opinion as to what the best way is, and I'll take you through the data and why I've come to that conclusion. And then I'm going to talk again about how do you know that your drying is working like it's supposed to? What are the tests that you can do? What do you look for to make sure that your drying is doing what it needs to do? Okay. So before we jump into that, why do we dry our beans? Why is it important that you dry your cocoa beans?
I'd say mold reduction, control the mold level.
Yeah, I think that's a pretty good answer, right? And so your beans are going to go somewhere else, right? If you're a farmer and you're producing beans, the likelihood that you're using them on your farm to produce chocolate is pretty low. So you're producing a raw material that you're going to ship to somebody else. And if you take a bag of wet beans and you put it in the hold of a ship, and it spends, I don't know, 20 or 30 days crossing the ocean to get to where it's going to go, when you open that up, it's just going to be a hot mess of mold, and it's all going to be ruined. So drying your beans puts them in a form that's stable for logistics and to be able to send to your cocoa producers or your chocolate producers. Okay, so once we fermented the beans, at the end of fermentation, your beans are really, really wet. They're upwards of about 80% moisture. And we've created some acids during that fermentation, right? Remember, when we're talking about fermentation, we create two types of acids, basically. The volatile ones are the ones you can't smell, and then are the ones you can smell, and the non-volatile ones that you can't smell. So not only are our beans high in moisture that we need to reduce that moisture down to stable levels, but those volatile acids, those acids that we can smell, drying is one step in our process where we can get rid of those. We can make those disappear if you dry right. So, and the volatile acid that we're typically dealing with is vinegar, right? It's the acetic acid. And nobody here, I'm assuming, enjoys drinking vinegar. It's just not a pleasant taste profile. So it's not something we want to be present in our beans, even though it's really, really important that it's there at the fermentation step of our process. So if we dry our beans too slowly, and Lloyd, you're spot on, what we get is mold issues. If we dry it and along with mold comes some toxins, right? Those molds that we talked about yesterday are going to produce things that are poisonous to us. And so obviously killing your customer is a terrible business model. We don't want to do that. But on the other side of that coin, if we dry those beans too quickly, what's going to happen is you're going to case harden your bean. You're going to dry the outside of it so much that the moisture that's in the middle of your bean can't get out now. And it's going to rot from the inside out. The other thing that happens if you dry too quickly and you case harden the bean, right now we've got a shell forming on the outside of our bean that's super dry. That acetic acid, that vinegar that's trapped inside the bean can't go anywhere. And now you've got beans that are going to rot from the inside out because you've trapped moisture in there, but they're also going to taste super sour because you've trapped that vinegar on the inside of your bean. Okay. So before we talk about what the different ways are to dry and how we do it, let's talk about just what are the attributes of drying? What are we trying to achieve? And what are the things that are important regardless of the method that we use? So what we're really after here is we want our beans to go from the 80% moisture, the 80% moisture that they are in fermentation down to 6 to 8% moisture so that we can ship them someplace else. Now, why 6 to 8%? That's a weird range of numbers, right? If we go less than 6%, what happens is the bean gets so dry it becomes brittle. And when somebody like Nick goes to work with it, when he goes through his winnowing process and it goes through his equipment, it's all going to turn to dust, and he's going to end up having really, really high waste numbers because the nib, or the inside of the bean, which looks like this, so if you dried it out, is gonna fracture so much that it all just goes to trash, and it'll never get turned into chocolate. So your customer's not going to be happy because his costs have now skyrocketed because he's throwing out all the good stuff that is needed to make chocolate. Above 8%, that's where we're going to start to have molding issues and holds of ships and in bags. So it's pretty important to get it between that 6 to 8 level, regardless of how we dry. So, and again, regardless of the method that we use to dry, what we're looking for is hitting that 6 to 8% moisture somewhere between 5 and 7 days after you've started your drying. Less than 5 days, we're going to get into case hardening, right? That problem that we talked about a few minutes ago, where the outside of your bean becomes so dry that the acids and the moistures that are trapped inside can't get out. And longer than 7 days, we're back to having a pretty good likelihood that we're going to have mold and toxin issues in our beans. Okay. Again, regardless of how we dry, having air moving over your beans is going to help take the moisture away and make sure that we can hit our target moisture in 5 to 7 days. So as we look at a couple different dryer designs here, I'm going to talk a lot about why I've designed some of these the way I have and why airflow is really, really important, both how it comes into the dryer and how it gets out of the dryer. You also want to make sure that you're moving your beans around multiple times a day. So if you've got, most of the time when we're drying our beans, it isn't, a single cocoa bean laying on something, right? It's a pile of cocoa beans. They're 2 or 3 or 4 centimeters thick. And if the sun is shining on them and we've got air trying to move below it, what happens if we never ever move that pile of beans is that the top will dry and then the bottom stays wet. So we want to make sure that we're taking our hands or a rake or some sort of utensil and maybe every 4 to 6 hours coming out and just moving those beans around, mixing them up so that they're homogeneous, and the stuff that's on top gets mixed to the bottom, the stuff that's on the bottom gets mixed to the top, and that way they dry equally. And the other thing that's really, really important to remember is that your cocoa bean at this point is about 50% fat. And one of the things that fat really likes to do is it acts like a sponge for flavor. So if you've got any strong flavors in the area of the beans you're trying to dry, these things will pick up that flavor and then they will ruin your beans. Why do I care about that during drying here? Because if you're trying to find a way to dry your beans faster and you're burning something, I've seen people burn everything from tires to rice hulls to shirts to shoes to piles of gunpowder. It doesn't matter. If you start a fire and try to dry out your bean is going to taste like smoke, right? It's going to taste like smoke and whatever it is you're burning. Smoke and diesel fuel, smoke and sulfur if it's gunpowder, smoke and rubber if it's a tennis shoe. Just be really aware that if you're trying to burn something to dry your beans, you're probably going to ruin your bean, okay? So, all right, so with those as sort of the fundamental things of what's important regardless of the method of drying, let's talk about some common ways that are used to dry around the world. The simplest, most common way that's used all around the world is just direct drying in the sun. And here you can see, we'll look at a bigger picture of this in a minute. This farmer just has jute bags laying on the canvas bags laying on the ground, and he's thrown his beans on top of that, and it's a single bean. This is an example where it's just a single bean lying on the ground with the sun beating down on it. It works okay. There's nothing wrong with that. This method is hard to scale, right? And so if you're trying to dry multiple kilograms of beans, this is just a really difficult way to do it. And it's also very difficult to keep this out of the rain, right? So cocoa bean just happens to grow in places where it rains regularly. And so when it rains, getting those bags up off the ground so you're not letting them soak in pools of rainwater is just a difficult thing to do. It can work well if you can manage for the rain and you don't have sufficient volume to require larger systems. What you lose in this is airflow. There's no way for air to get up underneath your bag and kind of move over your beans and carry the moisture away. But lots, hundreds of thousands of farmers around the world do this. It can work well. For you guys, I'm going to recommend something different. And the thing that I'm almost always going to recommend is a variation on this. So this is a solar dryer. Essentially what it is building a greenhouse with tables inside that have holes. We'll look at some more detailed plans here in a minute, but on either side of this house, there are tables that have holes through the bottom where you pile your beans on top, and then air moves through those beans and carries it away. I built the 2 largest fermentaries on the planet, and this is the design, or variation on this design is what I use for those, because it's so effective and it's so cost effective. You can almost always use local materials. The only thing that you typically have to import or source that's not local is some version of this clear. This is just clear plastic tarp on this one, plastic film. But sourcing the clear protective plastic material becomes really your only significant cost component, and even that is relatively low. Where we run into problems with this design is if you're in a part of the world where, or even on the wrong side of the mountain, right? If you're on the rainward side of the mountain, if you get a tremendous amount of rain and you get more than 2 days of cloud for every 5 days of sun, this is going to be a difficult method for you to dry your beans in 5 to 7 days. And when we've encountered those scenarios, there are ways for us to modify this design and use supplemental heat sources. This is still, in my opinion, the best way to dry beans, but we may have to have a couple different versions of this depending on everybody's local climate. Where you guys are at, for the most part, unless you've got some specific micro climates where there's just tremendous amounts of rain day after day after day after day during harvest season, I think this is probably going to work pretty well for you. The direct fire is also used, and this is one that I'm almost never going to recommend for anybody. This is, again, is where somebody's burning something, right? So this is almost like a charcoal grill type setup where they've built this structure that they put wood in underneath it and then use that to heat the top of it. Very few people do this anymore because I think almost everybody understands it's just not a good way to add value to your beans because you're adding smoke flavor to it. But I do want to just be transparent that there are some places in the world that still do this. And then the last version, or the last category I'll talk about, is mechanical drying. And that's using larger pieces of equipment to generate the heat and try to dry it more rapidly. So this particular one is a dryer in the, it looks like a jet engine, doesn't it? It's a gas flame dryer in the Dominican Republic. And over here where you can't see, but there's a big rotating drum, and this is just blasting hot air into the drum to dry it very, very quickly. Pretty expensive, right? Now you're burning a tremendous amount of, in this case, LPG, your liquefied gas is going into there, but there's a number of other machines that will do this as well. Some of them work okay. I've worked with, I installed a couple of them in Indonesia, actually. But for the most part, it's just a really expensive way. It's capital intensive, requires lots of energy or gas infrastructure to be able to operate. And frankly, in a place like Jamaica where you're blessed with the beauty of the sun, I just don't see a reason to go with a mechanical dryer. Okay. So now I'm gonna look at some of these a little bit more in depth. And this is starting with that first one we talked about, the sun drying. Again, this is the same picture we looked at. We've got canvas bags with beans and chickens on top of them. And it's a very, very typical way to do it. Here's another way. And this is in Asia, where you've got bamboo mats that have been rolled out. This farmer is trying to get some height off the ground, trying to generate some airflow through his bamboo reeds. But again, the gap between the ground and the bed is maybe only 2 or 3 centimeters. And so he's not really going to be getting any effective airflow through here. He does recognize that this is also helping him keep it off the ground when it rains. And now he's got this blue tarp. And what he'll do is he'll stretch this tarp over the top of his beans when it rains, because they're not sitting on the ground, right? Unless it's a lot of rain, he's not going to be sitting in 3 or 4 centimeters of water. It rains every day. It's maybe a tenth of a centimeter of rain. When it rains, he pulls his tarp over it. When it stops, he pulls his tarp back, and he goes on his merry way. It's not a bad way to dry. Very, very cost effective to do it. It's not scalable, right? And so if he's trying to dry kilograms and kilograms of beans, he just can't create enough of these reed tarps or reed mats to be able to dry it. Another way of sun drying is on concrete patios. And so this is pretty commonly used in some places in South America. And typically what they'll try to do is create your concrete patio at a little bit of a slope, right? So instead of having a perfectly flat piece of concrete that you might want for your house, for example, right? Because you don't want your house to do this, is that when they pour these concrete pads, they will get it to do this to try to encourage rainwater runoff, right? That way, yeah, your beans are still going to get wet, but the hope is that the rain is going to clear off of your patio fast enough that it's not going to cause problems for your beans. It works. So it can work okay. We're going to look at some different drying rates here in maybe 20 minutes or so. What you lose here is time. So assuming it doesn't rain every day, this can effectively dry your beans in that 5 to 7 day window, but it's going to push really close to the upper end of that. And it's going to be much closer to the 7 days than the 6 or 5 days, which means that if you've got one rain event that is out of the ordinary, right? It rains one more time than it's supposed to, as Mother Nature tends to do. Now you've got a problem with your beans being wet for too long, and they're going to mold. And also the other thing that happens is as you're walking around on here, you're obviously going to be stepping on your beans, and so now you're breaking up your beans, and you're going to be causing problems for your chocolate maker. Your chocolate maker wants to get nice large whole beans. They don't want to be getting bean fragments, and so this is probably not going to be the best option for us. This other picture is in Brazil, where at this particular place, they put the drying rack on top of their house. They call them barcaças. And you can see that there is some bean depth here, right? So it's not just a single layer as it is over here. There's a couple centimeters worth of beans here. And what they'll do is a couple times a day, they walk up onto the top of their roof, and they just walk around through the beans. And the action of walking through the beans is sufficient to kind of mix them up and get them equally exposed to the sun. I don't love this idea because now you have to have some way of getting your wet beans up there. That's just difficult to lift. This has probably got 1.5 tons of wet beans on his roof. So you're manually carrying 1.5 tons of wet beans up here somehow. And then you're putting that additional weight on top of your house. Lots of houses collapse because people don't understand the structural requirements, or the implications of putting a ton of wet beans on top of your house. So I don't think that this is a great option, but it's an interesting way that people have solved for sun drying in their specific area. This is a little bit of a hybrid version, right? And so the second one I talked to you about was the solar dryer. We're using some clear material to create a greenhouse effect and then shielding it from the rain. This is a little bit of a combination of direct solar drying, and they can drop so this is clear transparent plexiglass that they put over the top of this. When it rains, they just take the stick out, and then this covers the the top of it, still allows heat to be generated, but protects the inside from the rain. And when it stops raining, they just open it back up again. It's okay. It's actually not a bad design. It's more practical for small farm holders where all you're doing is maybe loading 1 or 2 of these up. It's going to be more cost effective to build the solar dryer that I'll talk about here in a few minutes. But it's an interesting way to do it at smaller scale. You're off the ground, so you've got good airflow. This isn't very wide, so you can physically lean over and rake the beans in or load the new beans on. It's easy to work with, and you can protect it from the rain. It's not bad. It's just not scalable, and it's going to be expensive if you try. In places where it's really very wet, this is a larger drying facility down in Ecuador. Basically, they've taken a version of this, and instead of having a roof on a hinge, they've got a roof on rolling tracks, right? So when it's sunny, they'll take this entire top of the roof and it rolls back on these tracks, so that on top of this, what happens is the sun can beat down on the beans and dry them. And then when it rains, they just roll this big galvanized roof back over the top of their beans. As you can imagine, it's fairly capital intensive, right? You're pouring concrete, you're creating rail systems, you've got this big metal roof that you're moving back and forth. Whoops, I don't think that this would be appropriate for where you guys are at. In this particular region in Ecuador, it does rain a lot. And so this is, really was necessary for them because they couldn't afford mechanical dryers, and they just didn't have enough consistent sun to be able to dry the beans without them getting wet all the time. I don't really think that it's for you guys, but you should be aware of it. All right, so the summary of direct sun drying is it can be pretty inexpensive, as it's almost always just beans in the sun. And the materials necessary to do this are local stuff, right? Bamboo, local woods, and it's pretty easy to do. Why do we not like this very much? Can't really scale it up to larger quantities. And it's very dependent upon what Mother Nature gives you from a weather perspective. All right, so we're gonna talk a little bit more in depth about solar dryers, and this is the version this is the method that I like very much. And what you're seeing here is a front view of one of the designs that I implemented someplace, and we're going to use this as a demonstration to understand how a solar dryer works and what's going on here. So the general idea is we're essentially trying to build a greenhouse. So if we've got sunlight, sorry, let me go back. So what we've got here is a doorway that you can walk in, and you walk in through this doorway to load your beans on the left and right hand side, where there's tables that run the length of your solar dryer. It's a raised bed, so you can have air coming in from the outside, and there's a roof on top, so it's shielded from the rain. And really importantly, there's a gap on this roof to let the hot air, which is going to pick up your moisture, escape. Okay, so on your roof it's clear. On the front, where the door is and these windows are, it's clear tarp, and on the sides it's also clear tarp, because that's what's trapping all the heat inside. All right, so how does this work? All right, so after fermentation, we're going to take our beans and we're going to lay them on this table. This table is full of holes on the bottom of it, because that's what allows the airflow to move through your beans. Somebody's very excited about solar dryers. I love the enthusiasm. This particular design will allow us to dry somewhere between 50 and 20 kilograms of wet beans per square meter, right? So when you get to the point of designing your solar dryer, you want to make sure it's not too big and not too small. You'll understand how many kilograms of wet beans you have. And as a guidepost, we don't really want to go above 20 kilograms of wet beans per square meter, because then it's going to take too long to dry. If I put 30 kilograms per square meter on here, it won't dry within 7 days, and now we've got molding issues. Okay. Typically, what that looks like is our bed depth will be about 4 centimeters deep. And on this design, a 4 centimeter deep bed depth will give us the 15 to 20 kilograms per square meter of wet beans that will dry in 7 days or less. Okay, so how does this work? Remember, our roof is transparent, and so what you have in spades is the sun, and we're going to let the sun do all the work for you. So as the sun shines down and it goes through this clear roof, because there's sides on this, right? There's sides here, there's sides here, there's sides here. This whole thing is going to get much warmer than the outside is. So what happens when air gets warm? What does warm air want to do?
Moisture.
You got it. Yep, it's going to rise. So as your warm air rises, it comes out through this gap on the top, but it's going to be pulling air in from someplace else, right? You can't just have air going out without new air coming in. So as this air comes out the top, it's pulling in air from the outside. This air from the outside flows up through your beans. And because your air outside is drier than your air inside, it's going to pick up the moisture in your beans. And now it's going to heat up. And that air, which is now hot and rising, is now hot and wet and rising. It's very humid. And that moisture, the humidity in the air is coming from the moisture in your beans, is being taken out of your beans, goes into the air, and goes right out through the top of your solar dryer. Okay. What makes this work is that this table that the beds are on is perforated. There's holes in there because that's going to be what allows the air to come out from the outside and rise through your beans. It's also important that multiple times a day, you're going in there and you're mixing these beans up so that the top doesn't get super dry and the bottom stays very wet. Okay. So just conceptually, this is the basics as to how a solar dryer works. It's a very, very efficient drying mechanism that doesn't require any inputs other than the sun. Okay. So this is more of a side view of the thing we just looked at, right? So this is just a different perspective. You can see that you can walk through it. You've got your bean table here where you load your wet beans on, and in 5 to 7 days, you'll take your dry beans off of. This design here where we've got almost a gable on it where it's adjustable. There's a screw system which allows me to raise and lower this roof. That's more complicated than you need to have. And so I'm not going to recommend for you this exact design. We'll look at a variation on this design that's similar, but it's going to be much easier to construct. I like this because it's so efficient. You can use low-cost materials that are almost always locally sourced, with the exception of this plastic coating here. And it's a really, really scalable, consistent way to dry beans. Okay, let me just pause here for a second and make sure that I'm not missing any questions or discussion here we should have. Wow.
Scott, there's a question. Sorry. What are the sides made of?
So these sides, it doesn't really matter as long as it's clear material. So we're going to look at some pictures here soon where it can be as simple as like this, 3 millimeter thick clear plastic tarping, really, really inexpensive. The upside of this is that it's inexpensive and it works. The downside is it can be a little fragile, right? And so if you get, I don't know if hail is a problem in Jamaica or not, but let's say that hail is a problem, and now you've got the potential for things to puncture your roof, at which point you need to replace it. It's not expensive or difficult to replace it, but it does need to be replaced. Or probably not so much hail where you live, but there may be a windstorm may come up and may tear your plastic. This particular one is constructed using something much more rigid, and we'll look at some the trade names for some of these in a bit. But as long as it's a clear material that lets the sunlight shine through, it becomes a decision on your part. What's more important when you're building? Is it inexpensive materials in which case you may go with this, with the understanding that you probably have to replace this a couple times a year as it tears? Or do you want to spend a little bit more money at the beginning and use something that's more durable than this, but it's going to be more expensive and much less likely to break or tear? Okay. So either I did a really good job of explaining this, or I put everybody to sleep.
The question I'd ask, is there added benefit for false ventilation or air through the system?
Yeah, and we're gonna talk a little bit about that in a minute here. The answer is there can be, if so we're jumping ahead a little bit, but the answer is yes, we're going to get to that. That's a great question.
Elian had a question.
Oh, yeah. I was following the drying process. It seems as if the sweet taste around the cocoa is what is causing the mold. Would it be possible to wash it before we dry it? Is it recommended?
Yeah, so my short answer would be yes, it's possible. No, I wouldn't recommend it. And so if you've gone through your fermentation, most of your sugar has been consumed in fermentation. Remember our definition of fermentation, it's yeast eating sugar. And so after 7 days, your yeast has eaten almost all of the sugar that it's going to eat there. Now mold doesn't just grow on sugar. Mold grows on lots and lots and lots of things. And so what is going to, so at the end of fermentation, you don't have much sugar, but you still have lots of starch and you've got lots of protein. And those are food sources for mold. Sugar absolutely is a food source for mold, but really you don't have much sugar left by the time you're done with fermenting your beans. So the washing your beans, really all you're doing at this point is adding more moisture to your beans if you do that, right? And if your beans are already at, excuse me, let's say 80%-ish moisture to begin with, and this whole thing that we're talking about here is about removing moisture, and we want to make sure that we're removing that moisture in no more than 7 days. Well, the last thing we want to do is put more moisture into the system that we just have to take out, because you're not washing any sugars away. So if you've added more moisture, that means you're going to have to dry longer, which means that there's more opportunity for the molds to grow on the starches and proteins that are already there. Does that make sense?
Yes, got it.
Okay, so you can do it. I don't see an advantage to doing it, and all I see is risk to molding by doing it. It's a great question, though. I've had that a number of times over the years.
Scott, just a comment here. The Scientific Research Council here in Jamaica, they too, are you hearing me clearly?
I can, yeah.
Okay, right. So the Scientific Research Council, which is one of the national bodies here that deals with product testing and product quality guarantees and all that, they too have a prototype that they had developed a few years ago. I could try to get my hands on it, share it with you, and see if it could be tweaked to facilitate this type of drying.
Yeah. Yeah, that's great. So you're saying that your council has developed a prototype dryer already?
Right, a prototype dryer. We had gotten one for a group that was drying herbs and spices. So I don't know if it would be. It looks very similar to this. And it's the idea that, as you have said, the idea that you can have it outdoors without having to move back and forth when it's raining and all of that.
Yeah,
so I'll encourage everybody to look at it. But when we meet again Monday, I'll try to get my hands on a picture of it, to find out if they, what stage they're at with the development of it, if they sell the drafts or the actual dryers. So I'll update you. All right.
Yeah, I'd be happy to look at it. I think there's lots of different designs. This is just one version of it, but we're going to look at once we get to this point, we're going to look at a couple different versions, and we'll talk about the pros and cons of it. So I think once you understand the concept of how a solar dryer works, right, it's just heating up the air and allowing airflow to move through your beans and carry it away. There's lots of different ways to have this come about. But yeah, I would certainly be happy to take a look at what you guys already have.
Scott?
Yes, ma'am.
There's a question from Colette. She's asking if the fermentation takes place before the drying.
Fermentation does take place before drying. Now, that said, a little bit of fermentation can still happen on the drying table, right? And so I think, 99% of your fermentation is going to happen before you bring to drying, but it's not an either or type thing, right? It's not you're either fermenting or you're drying. By the time you put your beans on the table, there still may be a little bit of sugar left in there, right? Like maybe there's a 0.5% or 1%. And so I think, to answer in the previous question was about washing, and can you use that to remove sugar? And the answer is, yeah, you can wash it, but there's really not much sugar there to remove. There still may be a little bit, right? And if there's a little bit there, some fermentation could still be happening on the table, but it's 0.5% of the fermentation activity that's happening. Technically, from a scientific perspective, yeah, there may be a little bit of fermentation activity happening there. From a practical perspective, once you're on the table, there's no changes to flavor that are going to happen as a result of fermentation, even if there is just a little bit happening on the table. Okay. Good question. Okay, so because I'm a scientist, you're going to learn that every time I talk with you, I'm going to bring a graph or a chart to some point. I love data. Data helps us make better decisions. And so these are temperature profiles of different types of solar dryers, right? And so I think somebody asked the question of, well, what's the clear stuff made on the outside? These are all different versions of different types of clear stuff. And there's also a concrete slab thrown in there for good measure, because what we're trying to do, the answer I was trying to get to is what's the most effective way to dry beans? And if I don't test all the different ways, I don't generate data, well, how am I going to know what's the most effective way to dry beans? And so what I use to generate this data, and this is on this axis, it's just time, right? So over time, what's the temperature of the beans over time? And I measure that by using the same type of data logger that we use to do our fermentation data logging, where I program this little mini computer to every minute or every 5 minutes just automatically record the temperature. And then I can download it onto my computer and say, all right, what are the temperatures doing? And so this purple line, for example, we can see is the concrete slab, and we see it gets very hot during the day, and then it drops down at night and gets hot during the day and drops down at night. And all of them are doing that, right? They all follow the same general pattern, but there are differences in between them. And so if you've got a polyethylene film, which is just a clear plastic film, it's going to follow the line of this blue line, and it will correlate to over here. And so we can see this is the profile of temperature over time. But if we take all this data here and say, all right, what's my average and what's the highest it gets to and what's the lowest it gets to, that's what this is telling us. And so this is telling me for my polyethylene film, the cheapest clear film that I can find, it's giving me an average temperature of 30 degrees Celsius, and it's ranging between 40 and about 12 degrees here. This is going to be helpful. Well, let me hold on. This information is really helpful for me to understand what's going to come on the next slide. We're going to look at some more data. Once I understand what the temperatures are, what the average, what the ranges are, I can then figure out, all right, how quickly is my moisture disappearing and how many days does it take me to get to my 6 to 8% moisture? The other thing that we want to remember is that warmer is not necessarily better. If we go higher than an average temperature of 40, then we've increased our likelihood that we're going to case harden those beans. And what happens when we case harden our beans?
one question there.
Well, hold on, before we do a question, if we go too high, right, if we go over 40 degrees as an average temperature, we case harden our beans, and we don't want to case harden the beans because
too much
that
moisture is
traps
in
the
the middle.
moisture on the inside. Sorry, Elian, did you have so you had another question?
Oh yeah. I was saying you talk about the plastic at the side, polyethylene. Do you have a grade that you have to use to prevent the plastic to interact with the product or something like that? The heat.
Not particularly. So your cocoa bean is never coming into contact with your plastic, right? So if we go back to the dryer design, the plastic is only on the external surfaces, right? So it's on the outside of this frame here. It's on the outside of this frame here. Your cocoa beans, the only thing your cocoa bean touches is this dark area here.
Okay.
So from a raw material standpoint, you don't really have to be concerned about food contact with your cocoa beans on this material, on this plastic. The thing that I would say is that you don't really want a plastic that is going to generate a lot of odor, right? Because remember, your beans are about 50% fat, and fat is a flavor sponge. And so if you find a plastic that just has a really, really strong bad smell to it, you probably don't want to use that. Even though your beans aren't going to physically touch the plastic, you run the risk of that smell being trapped in here, and then your beans absorbing that smell. Okay. Typically, plastic, most of your plastic will have some odor to it when you first start working with it, and that will go away after a couple of days. So typically what I would do when I build a solar dryer, I will build it and then let it sit in the sun without any beans in it for a week or two, just to give it a chance to air out and those odors to dissipate.
Okay, thanks.
Of course. And Colette, did you have a question as well?
I was saying when the beans are case hardened, they have too much moisture in the middle, and that will cause them to rot.
You're exactly right. Yep. The other thing that gets trapped in the middle with case hardening is the
vinegar.
You got it. You're gonna be teaching this next time, I think. Perfect. Okay, so we looked at the temperature profiles of just a concrete slab and then 3 different types of drying. One of these, Ilan, I think was your question of can we use, or actually, I think it was somebody else asked, could you add a blower to it to increase drying efficiency? So we looked at that as well. I've looked at that in a couple of ways. This particular one, the green line, uses the design that is just this and adds a fan to it to try to blow more air out. And so we can see that that doesn't really change the shape of your curve. It gives you essentially the same drying profile, right? So the one without the blower is this. The one with the blower is this, right? This is the PE film with the blower. We're almost exactly the same average temperature and almost exactly the same maximum and minimum temperatures. So just adding a blower to it didn't give any advantage to drying. There are some more sophisticated drying techniques that use solar dryers that we're not going to talk about today, that I've also evaluated that that do add benefit. And if we want to have sort of a advanced drying conversation, maybe as a 4th session, we can look at that, but that gets into much more difficult to manage infrastructure, and is going to be almost the same conversation as we had when we talked about mechanical, the gas drying of your beans, is it requires machines and equipment and a liquid, natural, an LPG gas source to be able to operate it. But it definitely is possible, and I've got the data for that as well if we want to explore that at some point. I don't have that as part of today's conversation though. Okay, so this data was helpful for me in coming up with this data. And so what this is,
Scott,
yeah.
I said ask question. if we don't necessarily need direct sunlight and just heat generated from the solar housing, would it be possible to have a rack system, meaning 2 trays on top of each other?
That's a great question. You're saying almost like bunk beds, right? Stack these until there's multiple.
Yes.
That's a really good question. I don't know the answer to that. I've never looked at that. My gut feel is that, yeah, I think it would work. I think you're going to have to, let me think about that for just give me a minute.
You see, that's why I was looking at the idea for air movement through, if we would force air through the housing, we would have clear circulation, air movement there, and the heat generating, because the air movement doesn't affect the overall heat that is generated.
Yeah.
So as long as we have continuous movement, air movement, we're moving moisture, and the temperature is constant, can't see why it won't work.
Yeah, I'm kind of with you there. I mean, so I think, so what I'm thinking about, I'm trying to do a little bit of mental calculation. So what we're going, so the implication of doing a racking system, and I think it's a really interesting question, by the way. So I like the way that you think. So the implication of having multiple racks in here now is that your relative humidity inside this structure is going to be much higher, right? Because you're physically putting more moisture into it. So that means we need to get that moisture out.
The same here that is getting in is going to be working 2 times. So it's going to be letting out more moisture because it have to work 2 times. It have to work at the bottom rock, at the top rock, and then it pushes out more moisture.
Well, but yeah, so the answer is yes, but I think that's, he's a little bit further ahead of where we're at, and that he's already trying to solve for that, I think, with his question around adding a fan to adding a blower, right? So by putting racks in there, we're putting more moisture in there, which means we have to get that moisture out faster, which means we need more makeup air. The way we do that, I think you're spot on, is the blower could help with that. But I also want to be clear that I don't know the answer for that, right? I've never done that. I would love to work with you in designing that and finding the answer, right? I think it's a really interesting question.
Yes, that's something we could look at. Yep, I do agree.
Yeah. Oops. That's part of the reason why I love doing this, right? Is that there's smart people all over the place who have all kinds of great ideas. And like I learned something too. That's a really interesting idea. Okay, so we talked about the drying profiles and how quick, what the temperatures are doing, what the averages and ranges are, but really what we want to know is which dryer is allowing us to get to 6 to 8% moisture in less than 5 days, less than 7 days, right? And so what this is looking at are different construction materials, right? This is something, just a polyethylene film. This is a solar Tuff is a thicker plastic-like material that is very durable but costs a little bit more. This is your polyethylene film with a blower, and of course the concrete slab. And then each one of these are looking at different load capacities in your dryer, right? And so if you remember, before I said that we were sort of in the 20 to 25 kilograms of wet beans per square meter of drying capacity in this solar design. Well, how I get to that conclusion is by, when I build my dryers, I will load them up with 15 kilograms per square meter. I'll load another one up with 20 kilograms. I'll load another one up with, and so on and so forth. And then I measure how long does it take with each different type of construction material to get me to 6 to 8% moisture. And so where we landed on is, for this particular design, having your roof made with this material called solar Tuff allows us the ability to dry up to 25 kilograms per square meter in less than 7 days to a maximum moisture content of 8%. This was the most efficient combination of load and construction materials to get us to our target moisture loss and our target time. Once we exceeded that, right? So if I go higher than 25 kilograms per square meter, we can now say it's taking me an extra full day to be able to dry that. I should say that this data is averaged of multiple replicates and already allows for 2 days of rain events to be occurring during that 7-day window. So another way to say that is that if you're expecting more than 2 days of rain per week, that we're probably going to need to think of, and when I say 2 full days of rain, I mean full days of rain, rains the whole day. If we think it's going to rain 3 days or 4 days during the week, a solar dryer probably is going to need some supplemental heating and air movement systems to be able to get us to our target moisture loss. Okay. So we're going to look at a couple different versions here. I think we looked at this briefly. This particular solar dryer, I don't really like. It's obviously very large. We still have our central aisle that we can walk down, but because it's so large, it's difficult for somebody to reach these beans here, right? This is, I don't know, 5 meters across or something, and it's just difficult to load your beans. It's difficult to rake them and move them around. In addition, what design principle is missing from this that would make a solar dryer most effective? What are we not seeing here that we would want to see in a solar dryer?
The outlet post in the top of the hose.
Yeah.
I don't see any outlet in it.
Yeah, there's no vent. There's no way for the hot air to get out, and the hot moisture, or more specifically for the moist hot air to get out, right? So yeah, it'll eventually sort of just come out through this doorway here, but this is a very inefficient design of a solar dryer. I don't like this one at all for multiple reasons. This one is probably more similar to what I would propose for you guys, in that it doesn't, you know, the schematics that I put up earlier on mine had this adjustable gable system where you had, you know, openings on both sides and a screw mechanism to be able to raise and lower that. That was important for the area that we were in. For you, that's not important. And I think I would go more with this lean-to design. And what I would do is whatever direction the prevailing wind blows, if the wind blows this way, right? So from this side to this side, I would put your blocking portion of your roof here. I do not want the wind blowing this way. Why do I not want the wind blowing this way?
It's going to blow off the top.
Well, so part of that is true, but really the main reason why I don't want it blowing that way is when it rains, I want the rain blowing into your tarp here and hitting here and then draining down your side. I don't want the wind blowing your rain into this hole here, which is just going to, you know, fill your dryer up with water. So I would position your solar dryer with this lean-to type, you know, venting system, with this portion of it pointing towards the direction that the winds typically blow. Okay. And here's another version of essentially the same thing. This one I don't particularly like because I just put the beans on the ground, right? And now you've got, you know, the whole point of doing a solar dryer is to create hot air that generates airflow. There's no airflow happening here. To try to compensate for it, they put a fan here, and it helps a little bit, but it's nowhere near as efficient as to if you just lifted this up the ground, you know, by half a meter or a meter. And then this is actually a pretty robust design here. This material here is that solar Tuff. So you can see it's much harder. It's a corrugated plastic material that's very, very durable. You've got that lean-to type venting structure, right? So the winds are coming from the right side of your screen, blowing to the left. So it's not blowing moisture in. And these tables, you can kind of see through them, right? It's a mesh material, so we can see very clearly that they're perforated. And as you stack your beans on it, it's very easy for the airflow to come up through the bottom, take the moisture away from your beans, and just evacuate out the top of this. This is probably a similar design as to what I would recommend for you. Really, the only difference between this one here and this one here is that this top one is using a very low cost polyethylene film. This one is essentially the same design. It's just using a much more durable solar tough plastic material. Okay. Before I move off of solar dryers, do you guys have any questions that we want to talk about that we didn't talk about?
What's the lifespan for the plastic?
Well, it depends on the environmental conditions, right? And so something like this, if you get well, it depends on how much wind you're getting, right? If you get a lot of really strong winds, this is going to tear relatively easily. If you don't get a lot of wind, you might expect, and plastic will just degrade in the sunlight, right? So probably 2 or 3 times a year, you would be replacing this at minimum. If you get a lot of wind and you're tearing your plastic because of the wind, you could be replacing this all the time. This material, and I forget the solar tough, this part of why they call it solar tough is it has an, so let me back up a little bit. The reason that your plastics break down in sunlight is because the ultraviolet light in the sun decomposes the plastics and they become brittle and tear. So this particular material is called solar tough because in addition to being made of a clear plastic, there's an ultraviolet blocker that's added to that specifically so that your material won't become brittle quickly and it will last longer. So this particular material, and so there's a specification for it, and I just don't remember the specification. This material lasts for years and years and years. It's far more durable than this material is because one, it's much thicker and it has an ultraviolet chemical added to it to protect it from decomposition in the sun, whereas this material is going to be the more economical version. It doesn't have either of those things, right? It's thin and it doesn't have a UV protectant added to it. But I can look up the solar tough spec and get you a more precise answer. I just don't have it memorized. Oops. Okay. So I know we spent a lot of time on solar dryers. That's because I believe that this is the best option for you. We're going to talk about the other ones, but we're going to move past them really pretty quickly. So the direct fire one, again, I just don't like this. I've seen people burn everything. It almost always just ruins your cocoa beans. And then, again, you guys you've hit the lottery with your genetics. You've got such good genetics and such good flavor profile. This is just going to ruin your beans. And so I strongly, do not advise you to explore this. And then the last version is of course the mechanical drying. There's a number of machines that are built towards this. This is a large rotary drum machine that is perforated on the bottom, and you load your wet beans into it, and then it just slowly rotates while, and we can't see it, but back here through the sunlight, there is a boiler that is burning natural gas to warm up a heat exchanger that heats up the ambient air, and it blows that ambient air, which is now hot, through the bottom of this equipment, which was perforated, to try to dry out the beans. I've used these a number of places in Indonesia. It works fairly well. I mean, there's always a downside to it. The most significant downside is this is just really expensive, right? This is a big piece of equipment. It requires lots of electricity to turn it. It requires lots of liquid propane to operate it. If you guys are interested, I'll talk in more detail about it, but I just don't think it's a good solution. And of course, we've got, this option over here where you're literally just burning gas and, shooting hot gas into a drum to try to dry it. Again, I don't think this is what you guys need. If anybody's interested in speaking about it more in depth, though, we can do so offline.
Scott.
Yes, ma'am.
In the solar houses, instead of putting it on trays, can it be put in rolling drums as well? Meshy drums, they're round, but it mesh, you put the beans in it. So when you're ready, you just turn an angle and all the beans just turn in it and get here.
If I understand the question, instead of using tables like this,
right?
You're asking, could you just put a drum in there and roll it?
A mesh drum.
Yeah, I mean, So I think if you've got 1 or 2 mesh drums in there, it would work, right? Because if you line this up with mesh drums, now there's no place to roll it, right? Because it's a drum sitting next to a drum, sitting next to a drum, sitting next to a drum. Conceptually, I think it could work, but what you lose is you're losing scale, right? So you're only going to be able to fit a handful of drums in there because you need the space to be able to roll your drum.
Okay.
And your construction costs are going to go up. Your raw material costs will go up. So I do think it could work, but I see a number of disadvantages that make this general design probably a better design.
Okay.
Interesting question, though. I like it. I like the thought process. Okay, so now that we talked about a couple of different ways to dry, and we talked about, well, what's important, what are we shooting for? How do you know when you're at 6 to 8% moisture? For you, those of you who are drying beans today, how do you know when you've hit your target moisture? Can you talk to me a little bit about how do you know when you're done? We may not have anybody who's currently drying today. I don't know. Okay. Well, so normally what I've seen is that it's and again, I'm a science guy, so I like a piece of equipment that will tell me the answer as opposed to me guessing the answer. But a lot of times people don't have the budget or the access or the knowledge to run the equipment. So at the very simplest terms, what sometimes I'll see is just the finger crumble test, right? Where you take the bean and you squish it in your hands, and if it does this, right? If it fell apart into dust and the shell came off, all right, it's dry, right? That can work. What you're not going to know, what that tells you is it's below 8% moisture, right? If it was still above 8% moisture, the shell is going to adhere to your bean and you're not going to be able to crumble it because it's too wet. And your fingers probably aren't going to be strong enough to just smash it. What it doesn't tell you is if you've gone too far, right? That bean that I just crumbled I've had, sitting in a bag of beans that I've had in my office. And here it's winter. It's like, I don't know, 6% relative humidity. It's very dry here today. So my beans are getting really, really dry. Because that bean crumbled so easily and so quickly, it's probably below 6% moisture. So it's a dry enough bean, but it's probably gone too far. And this finger crumble test won't tell you if you've over dried your bean, which is going to be a problem for your chocolate manufacturer. So I like the analytical equipment, but again, I'm a scientist. Of course, I like analytical equipment. So we're going to look at a couple pieces of analytical equipment. I'm going to start with the one that I like the most. So this thing that looks like a coffee pot is called, I'm sorry, do you have a question? Sorry, I thought, Ilan, I thought I saw you raise your hand, but. So this thing that looks like a coffee pot is what's called a Dickie John. Now, how it works is you load up it's just called a coffee pot. You load up your coffee pot with these beans, and then you push a button here, and it just tells you the answer. It takes about 5 seconds to read. It doesn't require any specialized knowledge. You can use it with a bunch of other crops. And most importantly, it is really accurate, and it doesn't require any specialized knowledge to run. It's super durable. You can drop it on the ground. You can leave it in your solar dryer. You can say mean things to it. It's not going to get upset at you. It's going to work every single time. The only thing that's required for it to run is a 9-volt battery, and this battery lasts for about 5 years. How do I know that? Because I just took that out today. I've had this thing for 5 years, and I took it out today to show you guys, and the battery was dead. So I just took it out to replace it. It's a really, really durable piece of equipment. The downside is it does cost a couple of $100s, right? And so you can find these for maybe $300 to $600. This is going to be the most cost-effective option that I'm going to give you. But that said, it's still $300 to $600, right? And so oftentimes what I'll see is, if each individual farmer doesn't have the means to buy one, and it doesn't make sense for each individual farmer to buy one, oftentimes what I'll see is that a cooperative will go in, everybody throws in $20, and then there's like a community one that they all use. That's a much more effective way to sort of use the tool. There are a couple other ones that I've got listed here. I'm not going to go through these in detail just because, you know, they increase in cost and they increase in complexity. But I do want you guys to be aware that there's multiple ways to increase your confidence that you know exactly when your beans are done. And if anybody wants to talk through these in detail, I'm happy to have a side conversation with you. But my recommendation would be for you to seriously consider this Dickie John as a way as the lowest cost, accurate, precise way to get a moisture reading on your beans. So the other thing that I'm gonna suggest that you do is this cut test. And we talked a little bit about the cut test on Wednesday. The cut test will tell you once your beans are dried, we're going to take 100 beans and we're going to cut them in half, and we're going to look to see what the color is on the inside, and if there's any mold or insects that have decided to make that cocoa bean their home. And the reason we do that is we're going to create a specification for our beans that says, and I'm going to put up an example specification here. We know that, so on Monday, I'm going to propose a series of trials for you guys. Those trials are going to be used to map the flavor that we get in a Cocoa of Excellence format so that you can say, all right, here are multiple different products that we can create, and then we know what the flavor is going to be coming out of each one of these different types of fermentation. Now, the reality is that each fermentation is going to probably contain some degree of all of these, right? We're going to have some purple beans. There's going to be some that are fully brown and don't have any purple in them. There's some that are going to be slaty. What we're going to want to do is understand if we're really happy with the flavor that we got. We're going to say, all right, I did fermentation number 2. I love the flavor that I got. And in order to get me that flavor, I had 10% fully purple beans, 80% purple brown beans, and 5% fully brown beans, or whatever, right? We want to count the color of the beans, and that becomes a specification that when we do that fermentation and when we do that drying, that if our cut test matches to those numbers, we're pretty confident that those beans are going to taste just as magical as they did the last time we did it. But this cut test becomes part of your internal specification for knowing if your fermentation and your drying worked as it was supposed to work, okay? And so an example of what that could look like is, and again, it's going to be different based on each fermentation, but we should recognize that there's always going to be some likelihood for some mold in your beans. And we don't want to say zero mold, because if it's zero mold and it's your specification, well, then you have to throw your beans away. We don't want to do that, right? We don't want your customer to go, well, you said there was never ever going to be mold, and then we found 1 or 2 beans that were moldy, and then they're going to be angry with you. So we're always going to allow for some small amount of mold and some small amount of insect infestation. 2% is a reasonable number. And then what we're going to say, all right, most of my beans, I'm going to be well fermented and fully brown, but part of what makes my magic work is I want some purple in there as well. And again, this is just an example of what a bean cut test spec would look like to give you an idea for it. But if we collectively want to do the trials that I'm going to propose on Monday, part of what I'll design is both the fermentation protocol as well as what are the tests that I want to run or that I want you to run, and how are we going to record this information so that we've got predictable, specifiable outcomes that we can use to create consistent products that we're happy and, more importantly, are going to be valuable for your customers. Part of what's going to be helpful for doing this is having some sort of picture guide to help you, right? Because if I say purple brown, right, this may be what I describe as purple brown, but you may think of purple brown as this. So what's helpful is to create a picture chart that says, all right, purple brown is anything in these 6 beans, for example. And that way you've got a reference guide that you or the farmer down the road or that your customer can use so that you're always speaking the same language. Okay. So any questions on that? Okay. All right, so we are fortunate for you guys. You don't have to listen to me drone on and talk much anymore. I'm approaching about the end of what I've got for you today. So the key points that I want you to take away from this is that 6 to 8% moisture is your target for your beans. That's what you're trying to shoot for. You want to get there between 5 and 7 days. If you do it too fast, it's going to cause problems. If you do it too slow, it's going to cause problems. And there's lots of ways to dry beans, but really what we're looking for is something that creates airflow, that takes moisture out of your beans and doesn't generate smoke and flavor that your beans will absorb. Part of what's going to enable that to work well for you is to be sure that no matter what design you've got, you're frequently moving those beans around so that they dry consistently. And the analytical equipment, if you can afford it, it's going to be a really, really helpful way for you to ensure that you've got consistency for your customers and that they're happy and willing to pay the extra price for the premium that you're going to be asking for. And then finally, part of that bean specification will be that cut test that we just talked about. So I think for Monday, what I'll do then, guys, is I'm going to start with a review, much like we did today, where you guys will go away for the weekend. You'll think about what I said. You'll either come up with more brilliant ideas or you'll come up with some questions about what we talked about. And I want to make sure that we've got some time for us to have a Q&A session. And then once we go through that, what I'm going to do is I'm going to propose conducting somewhere between 5 and 6 fermentation trials where you all create the cocoa beans that Nick has already agreed to turn into chocolate. And then I will, I am a judge in the Cocoa of Excellence, that I will evaluate those chocolates and create what's called a sensory map that will be useful for communicating to your customers what the different flavor profiles are, and will be, more importantly, useful for you guys in generating submissions for the International Cocoa of Excellence Awards that have a higher likelihood of winning the global awards.
What if I don't have any cocoa?
It's going to be difficult for you to ferment if you don't have any cocoa.
Oh my.
The other thing I'm going to propose to you is a new way to ferment cocoa that's going to be, so these trials that I'm going to propose on Monday are going to be based on box fermentation. And I'll have some specific designs and specific parameters, and I'm going to be very precise in that. Part of what I'm going to talk to you guys about, though, is a second round of fermentation that's going to be a type of fermentation that nobody does in the world, and would be unique to you if it works. To be honest, I'm not sure if it's going to work, but if it does work, it'll be designed to create very specific flavor components that are really valuable in Cocoa of Excellence Awards. And if it works for you, this would be a fermentation style that nobody else in the world is doing and is patentable. And I would just give you guys the patent. You guys can own it so that it could be something unique for you. I've got a whole wall full of patents. I don't need any more patents. But if it's valuable for you and it works, I'll just give it to you. So that's what I have planned for Monday. And that's all I have for today. Is there anything else that we guys would like to talk about on Monday or today before we close up?
What are you going to do on Monday? Are you going to tell us, or are we going to start the fermentation on Monday?
No, so on Monday, I'm going to walk you guys through what my proposal is for you guys to do some trials. I would join you if I could, but I can't because it's COVID and they won't let me fly there. So I'm going to propose the work that I'll be asking you guys to do, and then hopefully in 6 months, where I would be able to travel, I'd come and I'd be right there, shoulder to shoulder with you guys to do it as well. But on Monday,
okay, so we'll be doing it on our own on Monday.
Well, yeah. So what we'll be doing on Monday is going through what the proposal is, seeing if you guys are willing to do it, and then having some questions back and forth to make sure you understand what it is that I'm suggesting.
Okay. So I will have enough time to get my cocos.
Oh yeah. I mean, your main crop harvest hasn't started yet, right? So we've still got we've still got plenty of time for main crop harvest to come in. there's no urgency in you going out to source your cocoa in the next 2 days. You know, unless your pods are ripe today, right? You don't want to let them sit on the tree forever. But I think that the nice part about the timing here is that your main crop should be coming in sometime in about the next month, I think.
Okay.
Okay.
Scott, mind if I add? Back to the drying process. If I over dry and my moisture content is less than 6%, can we save the beans at that point?
So typically what well, it depends on how dry you've gotten, right? If you've taken it down to 1%, I'd say probably not, right? But your likelihood of drying it that far is pretty low, right? So let's say you're at 4%, right? You've gone just under the line. Probably what I'd recommend that you do is blend your beans, right? So the next batch you're going to make is going to be 7%, let's say. Well, if you blend your 4% beans with your 7% beans, and now you put them in a bag, they will equilibrate, right? The moisture from your 7% beans is going to, it's called mass transfer. It's going to move to your 4% beans. And then, you know, the whole batch is going to be something in between. It's going to be the average of whatever your 4% and 7% beans would be. That's how I would think about it. That's the easiest way for us to think about how to address that.
Beautiful, thanks.
Yes, sir.
Second question. Let's say I've got, say, £100 to invest on the two process, fermentary and the drying process. All things being equal, which is more important? Where would I put most of my money?
If you had to split your money between fermentation and drying, which is more important?
Yeah.
Yes.
Yeah, but well, 50-50, or do I go 50-50, or do I say my fermentation process is more important, so I put more energy there?
Yeah, you know, it's one of those questions. Are these things are linked at the hip, right? If you ferment,
I suppose the idea is that the end result, what drive the end result? Which one of these processes give us the better end result?
Yeah, the answer is they're both critical, and I know that's not the question you're asking, but the answer is they are both critical. You can get a perfect fermentation and completely destroy it with a bad dry. Now, we didn't go into the chemistry of drying because that's way more complex than the chemistry of fermentation. But there's lots of chemistry that's happening during your drying. And so in order for that chemistry to occur properly, you have to have had a proper fermentation. That sets up the precursors for the drying chemistry to occur. So a perfect fermentation with a bad dry is going to ruin your beans. A bad fermentation with a perfect dry is going to give you ruined beans as well. So unfortunately, there is no dry, you know, there is no this is better than that. They're both critical to have happen well.
Right, both critical. Okay, thank you.
Mr. Scott, how long does the fermentation process takes?
Yeah, so you're we're going to look. The proposal I'm going to give you is going to be between 5 and 7 days of fermentation.
Okay.
But for you, we don't and each one is going to give you a different result, right? And so your 5-day product is going to create a cocoa that tastes like this. Your 6-day fermentation is going to give you one that tastes like this. And your 7-day fermentation is going to create one that tastes like this. And so you're going to be able to create a range of different products. I don't think I would ever see a scenario for you where you would go longer than 6 days. Some fermentations around the world go as long as 7 days. I don't think that there's any value in us even answering that question for you, because you're that question being what happens with the 7-day ferment, because your beans are so good that they're not going to benefit from that long of a fermentation. If you collectively would like to answer the question of what happens with the 7-day ferment, I can certainly design that trial, and we put that together. That said, I think it's my opinion that you're going to get the best range of flavors in a 5 to 6 day fermentation.
Okay, thank you.
Sure. Okay. Any other questions for us today from your side? And by the way, guys, you are asking really, really good questions, and you're coming up with really, really great ideas. That's fantastic. I'm really impressed.
Definitely.
All right. Well, if there's no other questions, then I think I'll wrap up, and maybe I think Marcia maybe wanted to just say a word or two, but certainly do appreciate your time today, and I look forward to talking on Monday.
Great. Thank you so much, Scott.
Of course.
And thank you everyone for coming on early today as well. And I hope you enjoyed it. And it's just all that Scott has done today is just really showing us what goes into quality, what makes for quality. It is precision, it's consistency, it's investing in some forms of tools and equipment that gets the job done, and you can maintain consistency. So our goal, as Scott, he keeps repeating it, we're not here to do bulk chocolate, we're a small producing country. So our goal is to produce the finest and niche, something that stands out from the rest. So I thank you so much again, Scott, for this very scientific-based session. It was very enlightening for all of us, I'm sure. And on Monday, when we reconvene, if you have questions that were not asked or anything, you can always do them at the beginning of the session, as Scott did today, where we did the recap. Mr. Lewin, do you have any announcements? I think we have everybody's contacts. Did everybody complete the forms? Some person said they did not get the recordings from the last session. Sorry about that. We're gonna try and get those to you.
Yes, I did not get it either.
All right, sorry about that. Mr. Lewin, we'll
Hello?
get it to you. Yes, Mr. Dawkins.
Yes, are you from the Scientific Research Council?
No, I'm from Farmer to Farmer.
Oh, I wanted a contact for the person from Scientific Research Council.
I made contact with an Annalie Akins. She's supposed to send me an email with the dryer. They're actually using a steam dryer there now. Are you familiar with that type, Scott?
Yeah.
Right. So in the past, they used to offer the service where you could probably bring the beans and they would dry it for you to whatever scientific percentage. But she says they're no longer offering the drying service, but they're offering, I think, a steam dryer service to clients now. But on Monday, hopefully I'll get the picture of the dryer there. But you can always call SRC on your own, Mr. Dawkins, if you, but just give us until Monday to see if we get it, and then you can probably call back if we don't.
Yeah, there was some other question other than this that I would want to ask.
Go ahead, we have a few minutes.
No, not in relating to this, from the Scientific Research Council. There are some questions I want to ask there.
So you wanted like their contact number?
Yeah, I'm going to, yes.
You can Google it, but all right, you can reach them at 927-1771.
Okay, thanks.
Right. All right, are there any questions before we wrap?
And of course, you guys have my email up on here. So if any questions, feel free to email me, and I'll answer whatever I can.
Right. So it's Scott DJ and 065.
Correct.
At gmail.com. It's on the screen, Mr. Dawkins.
I can hardly see it.
You can see it? All right. SCOTT.
Yes. Okay.
DJ 065 at gmail.com.
Okay, thanks.
But before we wrap, I just want to get to know us a little bit better. Quickly, are there any chocolate makers on other than Nick? Anybody currently making chocolate in Jamaica?
No, that I know of. Well, except for the locals here, that they would roast the chocolate and make it into the little balls.
Oh, maybe we need to introduce Scott. Scott, we're not big on chocolate making, but we're big on this chocolate ball that we grate into a chocolate tea. I don't know what the equivalent would be for you.
Yeah,
thank you for that, Mr. Dawkins.
Yeah.
What they call it, chocolate ball, is it?
Well, just chocolate, I know it has.
Next week you find one and bring it to the training. Next week you find one, bring to the training so that we can show it to Scott.
And you add what, sugar and some spice to it and then grind it up?
cinnamon and nutmeg and milk and make a tea, and it's very nice.
I've had it. It's wonderful.
Yes.
Oh, what do you add to the chocolate though? To the ball?
I
Is it
don't
pure
know.
chocolate?
No,
Some
I
people
don't.
make it with pure chocolate. Some of them grate nutmeg in it.
Oh,
And then when you're boiling it, you add cinnamon leaf. And
right.
then you just put in
Ah.
the salt and milk.
Remember,
Okay.
it doesn't go through the same fermentation like what we're currently talking about. It's more,
No, it doesn't go. They just put it out to dry.
just put it out to dry. Yeah,
Yeah.
Mm.
yeah.
You'll see it when you come, Scott. I'm sure you can take it to somebody.
I can't wait.
All right, guys, thank you so much for joining. It's Friday. Enjoy the weekend, and we will see you back here on Monday.
Monday.
At
Same
1 o'clock.
time.
Unfortunately, I might not be on Monday. I'll be going to court. Yeah. No, there's a matter that I have to attend that court as a former cop, you know.
Oh, okay. We're
Yeah.
gonna miss your energy, Mr. Dawkins. You bring so much
Yeah.
flavor to the trainings.
Yes, yes. I'm interested in this training very much.
All right, but it will be recorded, so we'll send it to you.
Okay, thanks very much.
And if you can
Thanks.
join us afterwards or whenever.
So, and actually, before we go, I'm going to ask you guys a favor. So on Monday, think about what I haven't told you that you would like to hear about, right? If we need to go deeper into something, or when it comes to specifically cocoa, if there's areas that we haven't introduced you to that you want to dig into more, give me some of that feedback. It's always, again, a little bit difficult for me with a group of essentially strangers where I don't know your background to make sure that I'm hitting the right topics at the right level. So if there's material that you want to get out of this that you're not getting from me, just let me know and I'll adjust if I can.
Great, that sounds
Thank you.
good.
Thank you.
All right.
Yeah.
All right, see you all on Monday.
Okay,
Thank
thanks very
you.
much.
Okay, bye-bye.
Adios.
Adios.